This is part 9 in this YouTube series where I am writing the pseudo 3D racing game. In the last episode, I added green grass, a sunset sky, and 3D road segments projected into 2D screen space. The focus of this episode will be on moving the camera forward or backwards down the road. There will be adjustable speed, friction, that slows the player down when they are not accelerating, and the ability to go in reverse. I originally forked this project from an RPG game, so some of the code here is not mine, and before I start getting farther into the development of this game, I need to complete a few tasks to make the rest of this video series easier. Throughout the series, I have slowly removed the RPG elements when they got in the way of the racing game, but there is still some straggling code left. It is pretty boring to watch me do that work, but I will highlight the changes I made. I updated the Go version and changed the name of my module to QFlux instead of RPG Tutorial. After a search and replace and Go mod tidy that is done, I fixed several fix-me's I had sitting around. This included removing hard-coded screen dimensions, which I moved into a new config package. Finally, I broke the scenes into their own packages. To accomplish this, I had to create a registry of scenes, where each scene can register itself to the registry during their init function. That simplified my new game method a bit. In my main.go, I blind import each scene so the init function runs. As I was cleaning up and refactoring my code, I realized a mistake I had made in the last episode. I assigned the wrong z value to each segment, and I had a copy-pasta error here, which should have been scale bottom. These two things fix the blocky rectangle look of the segments, mainly because it correctly calculates the projection formula now. I actually had this problem many times while developing the code, so when I was recreating my steps, I did not find it unusual and was going to fix it in this episode. Now that that looks good, I am going to reformat how these vertices are written, because I want to change the color of the segments to an alternating pattern. Having the colors in single lines helps with this. Using modulo math, I can alternate between two shades of gray, and then put those in place of the static colors I had before. In order to move the player down the road, we need some sort of value to represent the player's speed. There is already a player struct, which I can add a speed field to. In order to calculate speed and acceleration or deceleration, I will need to define some new values. These are constant for now, but I will eventually tie them to the player, since the player may upgrade their top speed or a new car might have faster braking. First, I am going to create a delta time variable, which is easier in Ebitengine than other engines, so just setting something like this is helpful. I create some values for how fast the player accelerates and how much they slow down when they let off the gas. I also need a value for when the player is actively braking, which will slow them down faster than friction alone. I also set a maximum speed and some values for going in reverse, which are higher than reality, but during development, I want to be able to go forward or backwards quickly. Now that I have these values, I need to update the player's speed based on input. If the player wants to move forward, I can check for the W key being pressed. Notice I am using Ebitengine is key pressed instead of input util is key just pressed. This is a helpful tip to know. Ebitengine is key pressed returns true on every frame that the specified key is held down. For the racing game, this is the behavior I want, because I want the player to be able to hold down the key to accelerate. Input util is key just pressed only returns true on the frame that the key was pressed, which is useful for things like pausing, quitting, or entering a menu. I will first increment the player's acceleration by multiplying the acceleration value by the delta time. To prevent the player from going too fast, I will check if the player's speed is greater than the maximum speed, and if so, I will set it to the maximum speed. Next, I will check if the player is pressing the S key to go in reverse or brake. In this case, I need to decrement the player's speed by multiplying the deceleration value by the delta time. I also add another clamping mechanism to ensure the player cannot go too fast in reverse. To actually make the player move, I need to update the player's position based on their speed, which I do outside of the input checks. If I run the game now, you will see that the player can move forward and slow down. This is a bit more interesting to see if I add some logs to see what is happening to the player's speed. Now, I want the car to slow down naturally when the player is not pressing any keys. I will add an else statement here to check if the player is not pressing the W or S keys, and if the player's speed is greater than 0, decrement the speed by the friction value multiplied by the delta time. If the player is going in reverse, I will check if the speed is less than 0 and apply friction in the same way. When I run the game now, you will see that the player slows down when they are not pressing any keys. I can move forward and backward and apply brakes to stop faster. As I traverse the track, you may have noticed the position calculations seem to be wrong, and that the track itself is too short. Recall, I had set the track to have 1,001 meter segments and these values are not aligning with that. We will pretend for a moment I do not actually know what I am doing, and that I am not actually a game developer. I did, however, realize what my mistake was. Let me show you this fix now, and then I will explain it and adjust the code accordingly. The problem is when I calculate base Z I am using my lerp method, but that method only deals with uint values, not floats, which caps the values at 255. If I change this to be t times nz minus start z, the road will be the correct length, and the position calculations will be correct. I will fast forward this so you do not need to watch 17 seconds of a road flying by. I need the formula to be able to handle floats, so I will change the lerp method to use floats instead of uints. I actually want to create a lerp-f method, which deals just with floats. I also think this will be better served from a package any code can use, so I am going to create a new pseudo package. I will move my other two lerp methods into this package, and then I will create a new lerp-f method. This true-to-life measurement is the behavior I want for my game, and I am sure there are performance reasons not to do this, but for now, I want it this way. And do not forget, I am a game developer and I absolutely know what I am doing.